Greetings and welcome to this supplemental model on interaction effects. In particular, the purpose of this module is just to highlight a key issue that's been raised within looking at interaction effects within the analysis of variance. And in particular, whenever we do see a significant interaction with significant main effects, one of the issues that's been brought up in the literature is the need to make adjustments to those cell means. And so what we see is just an interaction, just a quick overview of what an interaction effect is. It suggests that there's a complex relationship and way in which two or more independent variables affect or produce change in the dependent variable. And so we might have, differential effects on specific participants. So, if we have a treatment control group, maybe this is, one-on-one tutoring to promote students' or individuals' reading level. So here this would look like, just one independent variable, two levels. The experimental group seem to outperform. But if we add in the second variable, so this would be like a 2x2 design where we have two levels to factor A, the experimental conditions, but then we have factor B. This is whether or not those exposed to the intervention or control are low or high risk readers. So high risk readers are the ones that might be more susceptible to having reading problems, whereas the low risk, they're not going to be susceptible. And what we see here is a disordinal interaction in which, regardless the one-on-one tutoring for the low risk readers had no effect for them. The people that benefited the most from the one-on-one tutoring were the high risk readers. And so if we were to find like a significant main effect for either factor A or B, and with combined here, this would be a significant interaction, is, we would need to go in and do a follow-up post hoc. And so generally we use plots of the cell means to inspect the group mean differences. Whenever we do find that significant interaction, that tells us then we need to do the follow-up post hoc analysis and understand the sources of the significant interaction. This is within interactions. We call this the simple effects. However, the use of cell means to make decisions around interaction effects has been called into question by many people. For example, Thompson says the plots of cell means do not reflect only the interaction effect dynamics. More specifically, Rosnow and Rosenthal report that the cell means are the combined effects of the interaction, the row effects, the main effect for factor A, the column effects, the second main effect, perhaps factor A or B or C, and then also the grand mean, the mean for everyone in which data has been collected. And so what researchers have for the last 20, 30 years have pointed out is that we need to make adjustments to those cell means. We can't just move forward with testing simple effects and interpreting what they mean. We need to make adjustments to kind of remove this. And this is an issue that's not really fully addressed within any undergraduate or graduate level textbooks. And so the purpose of this module is to kind of highlight the issue. It draws heavily on the empirical research, and so this module is not to be reviewed in isolation without reviewing the sources cited here, the Rosnow and Rosenthal, and also the Harwell. So as an example here, these authors provide an example data set within their article of 36 individuals, a 2x2 design, two levels of factor A and B. And we see here in the descriptive table all the means across the different groups. The overall grand mean was 4.5. And if we ran just a two-way analysis of variance, what we'd see in the table here is that we see main effects for both factor A and B, but we also find a significant interaction with an F statistic of 4.8 and a p-value of 0.036. So obviously this is less than if we use the nominal value of 0.08. One of the things we might conclude is that, the mean of the second levels of factor A and B, or 7 as we see in the table, is greater than had the greatest mean followed by the second level of factor A and the first level of factor B, followed by the first levels of factor A and B, followed by the first level of factor A, second level of factor B, with 3 here. What they point out, and this would be, they're pointing out that this is an erroneous conclusion, is that we need to remove that components of the main effects, because many statistical software packages like we used here, this is SPSS for example, it provides a graph of the cell means, and obviously it's telling us one story, is that for the first level of factor A, or factor A for each of the levels of factor B, their means are about the same, and so and we're seeing, you know, kind of a main effect there were larger differences on the second level of factor A compared to, you know, the first level. And so one of the things we would want to look at is the simple effects to kind of look at where the differences are. So if we just take the regular means and put them in a table such as this, we had that in the previous slide, we'd want to make adjustments to these cell means. And how we would do it, this slide just provides us the formulas for making these adjustments. And so within each of the cell m sub 1 comma 1, this is the cell mean for the first levels of factor A and factor B, whereas m sub 2 comma 1, that's for the second level of factor A, first level of factor 1. If we look at the row, at the end of each row, we see m sub 1 comma j, m sub 2 comma j. These are the row means, so we just add up those values for each row, divide by 2. Likewise for the column means m subscript I comma 1, m subscript I comma 2. We would just add up those each column separately and divide by 2 to get the mean. And then m period at the bottom right hand side there, that's the overall grand mean if we were to estimate the mean for everybody. How we'd make adjustments to these means is just simply taking those cell means and subtracting the row and the column means from them, and then adding the grand mean to their score. And this would give us the what Rosnow and Rosenthal call the residual effects. So again, we just implement these values and we could identify how how we can adjust the cell means. And so here, you know, here is the actual applied example of the data set. These are the same means that we saw 2 slides ago on the descriptive statistics table. In between the tables there, we have the formula, so we're just making the adjustments to the mean. And then the table at the bottom there is how those means would be adjusted. And what we could do then is either add or subtract that 0.5 or the negative 0.5 from the grand mean of 4.5. And so we would just replace those with those. So what the value we see in the table for A sub O and B sub O is 0.5. That is how the mean should be adjusted. So we're adjusting that mean up by 0.5 point. Likewise for A sub O and B sub 1, the mean would be adjusted downward by negative 0.5. And so if we were to graph these residual effects, this is what it would look like here in the table. This would look a little different than the means that were plotted, the cell means that were plotted with the ANOVA table on a couple of slides ago. And so this is just, you know, how we would adjust these. In those cells, we could just add or subtract those residuals to the overall grand mean of 4.5. As another example, Harwell kind of provides us a more in-depth elaboration of this, how it might look for a 2 by 3 by 2 design. So in this case, for factor A, we had 2 levels. For factor B, we had 3 levels. And then for factor C, we also had 2 levels. And so what we have, the values outside of the parentheses are the actual cell means. And then if we look at the last, I have row means labeled. Those are, if we were to add up the rows and just, you know, for example, 12.5 is equal to 10 plus 15 divided by 2. If we were to add 15 to 15 divided by 2, we get 15. Likewise for the row labeled A sub 2, the second level factor A, B sub 1, 5, we add up 10 and 0 divided by 2, so on and so forth. And likewise for the column means C1, if we were to add up 10, 15, 20, 10, 5, 0 divided by 6, we get our column mean of 10 there. Our overall grand mean of all scores in the data set is 10.42. Now, how would we make adjustments? And the adjusted means are actually reported in the parentheses here. And so what we'd want to do with those adjusted means is add or subtract them from the overall grand mean of 10.42. But how do we estimate those? The formula is provided there. It's M or mu sub JKL. That is, J is for the first factor A, K is for factor B, L is for factor C. And so what we're essentially doing is from each cell mean, we're subtracting the row mean, the column mean, Also the factor, in this case factor B across the sea level means. Then we would also subtract the mean for factor A, the mean for factor B, the mean for factor C, and then we're also then taking off for the grand mean. So the formula's there. Underneath the table to the left is what those statistical notation mean, and then I provided on the right hand side where we're getting all these values, and this would be, so for the cell adjustment for the first cell, mu sub 111, that's the first level of factor A, first level of factor B, first level of factor C. We would adjust it down by 3.34 point, and so we would subtract 3.34 from the grand mean of 10, and that would be the adjusted mean in that cell. So the unadjusted mean of 10 is biased upward because we haven't accounted for the main effects for factor A, B, or possibly C, but then also the grand mean. And so here's just where we're putting that value into the table there. And so what's important here is all this video module is designed to do: raise the issue, show you a couple applied examples, and give you the formula so you can work this out independently within your own empirical research. And so if we're going to graph these, and again, whenever we have interactions, it's always useful to kind of graph them. It provides a nice visual depiction. So for example here, if we're going to graph these to kind of show the reader or an audience what's going on here in terms of interaction effects, the unadjusted means are in the two graphs on the top. On the upper left hand side, this graph just for the 2 levels of factor A, the 3 levels of factor B, just within the first level of factor C, whereas on the upper right hand corner, it's the 2 levels of factor A, the 3 levels of factor B as we see on the x-axis, and this is just for the second level of factor C. These are the unadjusted, and so what we're seeing here is, kind of an ordinal interactions. We're not really seeing any strong crossing interaction. But if we use the adjusted means down below and plot them for the same groups, we're seeing a very different story. We're seeing disordinal interaction. So for example, within the first level of factor C, we're seeing the means for the second level of factor A decrease with levels of factor B. On the other hand, for the second level of factor C, that same group, the second level of factor A, their scores are going up. Okay, so what we're seeing here is depending on the level of factor C, the first level or second level, the second level seems to be promoting the scores of the second level of factor A as they are exposed to different conditions within B, whereas the first level of factor A, their scores are dropping within the second level of factor C as they get exposed to different treatments across. And so what's important to note within this is we can implement these adjusted, we want to make these adjusted means if each of our factors are between groups. So if we have factor A is a treatment control and factor B might be demographics, or for example, we have like a split plot or where we have a combination of between and within factors. So factor A might be a treatment control, and then we might have 3 levels to factor B, but factor B may be within subjects. So we have the same individuals getting exposed to different types of experimental treatments over, a entire academic semester across 6 months, in which, 2 weeks are exposed to this, another 2 weeks are exposed to this intervention, and the other one might be a control. And so nonetheless, again, the purpose of this module is to kind of raise a critical, relevant issue within experimental, educational psychological research in which we might be looking at interaction within a factorial ANOVA. And whenever we have a significant interaction combined with a significant main effects, we're going to want to make adjustments to the means to kind of get a full understanding of the picture of the data and how our variables are interacting to produce outcomes. This concludes this video module.